Hello, my people. I'm Mrs. Ekute. Once again, I welcome you to our class for today, and we'll be talking about the production of limes. The lime here, you may be wondering, is it the lime that is a citrus fruit? Well, we'll find out as we proceed in the class. So, what are we intended to gain? What's our intended learning outcomes? It's expected at the end of the video you should be able to define cement, you should be able to identify the limes and explain the processes involved in the lime cycle. So without much ado, now let's know what cement are. Now if you are asked what is a cement, what would you say? Would you say it's a binder? I'm sure you must have said yes, cement are binders. Really, cements are binders, and they are substances that sets and hardens and can bind other materials together. There are actually three classes of cement, namely the natural cement, aluminum cement, and Portland cement. But our this video is going to focus on only the natural cements. So what are the limes? The limes are actually natural cements. And how did you come about that name, the limes? It is because natural cements are obtained by heating limestone. So from the mineral from which the cements are gotten, we coined the term or the word the limes. There are different types of limes. We have fat limes, dolomite lime, lean lime, hydraulic lime, and so many others. But let's just talk briefly on the types of limes listed here. For the fat limes, they contain calcium oxide. Well, the percentage of calcium oxide in fat limes is within the range of 95 to 98%, and that means that fat limes are almost in pure form, and they slake rapidly when brought in contact with water and results in the liberation of enormous amount of heat. Now the impurities here are, we could say, they are insignificant considering the amount of calcium oxide present in fat limes. Then for dolomite lime, I'm sure in our class you could remember that we said dolomite is a mineral ore that contains calcium carbonate and magnesium carbonate. So when dolomite is heated in limited supply of air, dolomite lime is produced, and it contains about 30 to 40% of magnesia, which is magnesium oxide, and it slakes very slowly with lesser amount of heat involved, unlike the fat limes that slakes very rapidly when in contact with water. For lean lime still, it has 70 to 80% calcium oxide with about 5% of impurities like magnesium oxide and iron oxide. And the slaking time for lean lime is much because it slakes very slowly and has very low shrinkage. The hydraulic limes also have similar property with the dolomite lime and lean lime, in that the slaking period still is low, unlike that of the fat limes. And the hydraulic limes do not undergo much shrinkage. They can set even in the absence of air, and are preferred in marine works or works that require limited supply or entry of air. So I think that's an advantage for the use of hydraulic lime. So we now produce the limes. we'll be talking about production of these natural cements in a general way. We wouldn't be picking them one after the other because, like we said earlier, the limes are obtained from limestone. Limestone here is calcium carbonate. The chemical name for limestone is calcium carbonate, trioxocarbonate, um, carbonate 4 of calcium. So what then happens? Three steps are involved in the lime cycle. Three steps are involved in the lime cycle. The first step is calcination. The second is flaking, and the third carbonation. You know, when they say cycle, it has to do with going back to where you started from. So if you now look at the chemical equations shown, the first one here shows calcium carbonate being calcined or being heated to yield calcium oxide. Calcium oxide here is quicklime. So when limestone is heated, quicklime is formed and carbon 4 oxide is evolved. That is the calcination process. And I'm sure you can remember what we said calcination is from our previous class. That's our life class. Then the second step is the slaking process, slaking step, in which this quicklime gets hydrated to form slaked lime, which is calcium hydroxide. You can see it here, equation 2, showing calcium oxide with a molecule of water to form calcium hydroxide, which is slaked lime. If looking at the equations shown, sorry that I mistakenly went to the next slide, but based on the previous slide that shows the equations of the reaction involved in the lime cycle, we could summarize the lime cycle as this: that the formation of calcium oxide, which is quicklime, and the liberation of carbon 4 oxide on heating of calcium carbonate is a reversible reaction. Reversible in the sense that the calcium oxide, which is quicklime, can react with the carbon 4 oxide in the atmosphere, or even that which has been released, to form calcium carbonate again. It is a reversible reaction. And then one thing we should also note is the reaction, or rather the reactions involved for the formation of slaked lime. Hydration takes place. Then carbonation, the process by which calcium oxide and carbon 4 oxide react to form calcium carbonate, is called carbonation. So these are the steps or the processes involved in the lime cycle. So that is all we have for this video. I would implore you to join the class, the live class, to get more information on other forms of cements. And before we end the video, I would also want to chip in that natural cements are non-hydraulic, and by that we mean that they cannot set under water. So that is it on the limes and the lime cycle, the process for the manufacture of the limes. Thank you for listening.